All right, practice question set number 14. Question number 1 says a student uses a bar magnet to pick up a paper clip. What's going on here? Well, this is a magnet attracting a non-magnetized ferromagnetic material. And why does that happen? Well, because we temporarily align the domains in the non-magnetized ferromagnetic material. We actually make it a magnet, or at least for a short time, right? With the polarity of north and south. The answer is C, an alignment of the domains in the paperclip, which results in the paperclip becoming a temporary magnet. 2, which of the following diagrams illustrates the magnetic field surrounding a bar magnet? The shapes are all the same. The only thing we got to pay attention to really here is the direction. We know that the magnetic field outside of the magnet goes away from the north and toward the south. So the answer for this one is going to be C. All the field lines are going away from the north toward the south. Now, the exception to that would be inside. If it was inside, then we would say the magnetic field is from south to north, right? But we're almost always looking at the magnetic field outside, which is from north to south. The next question says we have 2 bar magnets here of equal magnetic strength. They're placed as shown below. The point P is the same distance from each of the bar magnets. We want to find the direction of the magnetic field at point P due to these. Some of you are going to probably try to draw some lines connecting the 2 together. Yeah, that works. Okay, that works because north is attracted to south, so field lines would join up. But in the end, I think the easier way to do this is to look at each of them individually. If this is magnet number 1, this is magnet number 2. Magnet number 1 causes a magnetic field this way, which is away from the north. And magnetic field number 2, or magnet number 2, causes a magnetic field this way, which is toward the south. What's the magnetic field as a result of both of those? Well, it's somewhere in between, right? So it's going to be up and to the right. The answer is going to be D for this one. Up and to the right. And numeric response number 1, which is a Venn diagram, right? You've seen Venn diagrams probably in math, maybe even in social class. We have 3 fields here: gravitational field, electric field, and magnetic field. We should be pretty familiar with all 3 of these fields now. The parts of the circles that overlap in a Venn diagram show things that they have in common, and then parts that don't overlap show things that they don't have in common. So we've got all kinds of different overlapping things and non-overlapping things here. So what happens when you have three different things within your Venn diagram here? We want to match the numbers of the regions in the Venn diagram above with the descriptions given below. Which field, electric field, magnetic field, gravitational field, can be directed toward the source? Not is directed toward the source, but can be directed toward the source. Is the gravitational field directed toward whatever causes the field? Yes. Can a magnetic field be directed toward whatever causes it? Yes. Okay. It can be directed toward a south pole, right, which causes a field. Can an electric field be directed toward the source? Yes, it can be directed toward a negative. So that would be all 3 of them, which would be which number? It would be number 7, right? Can be directed away from the source. Can a gravitational field be directed away from the source? Can gravity point away from the Earth? No, not in this world anyways, right? What about an electric field? Can it point away from the source? Yes. Magnetic field? Yes, away from the north toward the south. So that would be electric and magnetic. What's the answer for electric and magnetic? 6. It would be 6. So we've got 7, 6. Is inversely proportional to the distance squared. Is inversely proportional to the distance squared. Now this is a tricky one. It's potentially tricky at least. It doesn't have to be, but it's potentially tricky. We know that the gravitational force is related to 1 over r squared, right? It's gm1 m2 over r squared. So gravitational field is inversely proportional to the distance squared, right? Gravity works for this one. Okay, what about an electric force? Is it inversely proportional to the distance squared? Yes. Yes, it is. So electric works there as well. What about a magnetic field? Don't know. Okay, this is a great question to illustrate something that I've told you several times now. If you haven't learned it, it's not the answer, right? If you don't know that the relationship is inversely proportional to the distance squared, then it isn't. Got it? If you needed to know that it was, if it was inversely proportional to the distance squared, and you had a question like this, you would have had to been taught that. If you're not taught something, it's not the answer. Got it? So it's only going to be gravitational and electric. And when we look at gravitational and electric, which ones show gravitational and electric? That would be number 5, right? Number 5. It's directly proportional to the distance squared. So in other words, which one, if any, are directly proportional to the distance squared? Is the electric force directly proportional to the distance squared? Nope. How about gravitational? Yes. Gravitational is not, no. Gravitational is inversely proportional to the distance squared, not directly proportional. What about the magnetic force? So if you don't know, then it's not the answer, which means it's 8. Now understand, please, when we do this, we're not saying that, oh, we're picking 8 because we don't know. We're saying we're picking 8 because if you needed to know, you would know. Does that make sense? We're not changing the laws of physics and saying, let's just say 8 because we don't know. The laws of physics say that it's not directly proportional to the distance squared. Therefore, we're picking 8. But if you haven't learned that it is proportional to the distance squared or proportional to the inverse of the distance squared, if you haven't learned that, then you can trust that it's not, that that's not the correct answer. Does that make sense? All right, so the answer is 7658 for that one.